Good morning and welcome to today's webcast entitled Data-Driven Growth Forum 2021. This session is turning back time and adding structure to unstructured data for new insights. Before we get started, I'd like to first review a few administrative items. This session will run for 60 minutes and full participation will qualify for 1 CPE credit. In order to receive the CPE credit, you must attend and remain logged in for the entire session and respond to the required number of online questions. Questions will appear in the slide portion of your media player and may or may not be verbally addressed by presenters. If you happen to have a question, you will be able to submit content questions at any time throughout the webcast by using the Ask a Question box on the left-hand side of your webcast player. If you have any technical issues throughout today's webcast, please use the question mark button in the upper right-hand corner of your webcast player to access our online help portal. You can also submit these through the Ask a Question box in your player. You will receive a response from our technical staff just below. When the webcast is over, please do not completely close out of your web browser. The player will automatically refresh to display an exit survey. Please complete the exit survey and click the submit button. A notification indicating whether or not you met the CPE requirements will be sent to your email address you entered when logging in. If you meet both the duration and polling requirements, you will receive your CPE certificate via email approximately 2 weeks following the event. Now I will turn it over to Pete Irwin to get started.
Hi, thanks, Mari, and good morning, everyone. Appreciate you all joining us today. This is Pete Irwin. I'm with KPMG, and we are going to be talking to you a lot about the types of insights we can get from unstructured data. And specifically, we're going to take you through a couple case studies of how this has been done in the real world by some real companies. So Dylan, if you want to flip the slide. Before we jump into the case studies, I want to ground everyone a little bit on what we mean when we talk about unstructured data, right? So this may be intuitive or obvious to some folks, but I want to make sure we're all on the same page, right? At the highest level, we have two big types of data within organizations, right? We have structured data, which is primarily going to be qualitative data, meaning it's numbers or values, and then most importantly, the data has labels, right? So we know what each piece of data represents. Typically, this is going to be data in databases. Then on the other side, we have unstructured data, right? This is going to be more qualitative data. So text or audio or video or images, essentially data that we don't know what it means without doing some type of analysis or interpretation of that data, right? So these are the broad categories. And then there is a third category called semi-structured that's kind of in the middle. But for purposes of this, we'll just think of these two high categories, structured and unstructured. So Dylan, if you flip to the next slide, just a couple examples of what we mean by each of these types. So structured, like I said earlier, is primarily going to be data that's in databases, ERP systems, CRM systems, almost all of the financial data that organizations have, things in spreadsheets. This is all of your typical structured data. On the unstructured side, though, we're going to have things like data that you have in emails, data that you may have from surveys you've done, or data that your customers provide you. Call center data is a really common type of unstructured data, what the call center reps are saying in their voiceover, the notes that they type. Data and contracts is an especially big one because while you may have contract templates that you use, those almost always get changed by the sales team or the legal teams, right, and become text that you didn't expect in there, right? And then social media, of course, is another really big one these days that's unstructured. And analysts, as you see at the bottom there, do represent that about 80% or more of data within organizations today is unstructured. So this concept that we're going to talk about today is actually extremely important to make sure you as an organization understand what is within that data and what it really means to you. And so Dylan, if you flip to the next slide, what we're going to do today is talk to you over the next 55 minutes about two specific types of unstructured data and how we can get insights out of that. The first is going to be contracts, like I mentioned earlier, and then the second is going to be scanned forms. So if you have customers providing some type of information to you on forms that get scanned and turned into PDFs, you then need to get the data back out of that to make sense of it. So two really interesting case studies in my mind, but I think the concepts you'll hear really do apply to all types of unstructured data, whether it's contracts and scanned forms or audio or video or anything else that you need to get meaning out of. So that's just a little bit of an overview. And now I will pass it over to my colleague, Dylan, who's going to talk specifically about the contract use case that I mentioned.
Great, thank you, Pete, and good morning, everyone. My name is Dylan Cab. I'm a director in KPMG's Data and Analytics Center of Excellence, which we call ourselves the Digital Lighthouse Group. And my primary focus over the past 5 years has really been in the realm of leveraging artificial intelligence and some advanced machine learning to garner insights from unstructured data, and specifically unstructured data that's stored in your contracts. So what we have is a suite of modular artificial intelligence capabilities that we've developed over the years that are all stored within our AI platform called KPMG Ignite. And we work a lot with procurement, with legal, with internal audit and finance, help them accelerate their processes and their activities associated with, assessing, reviewing, understanding, and optimizing their contracts. So I always kind of like to start with, a scenario that you have a chief procurement officer, and the chief procurement officer goes to his category managers and he says, I want to know all of my payment terms for my IT software service contracts where our spend was $30 million or more last year. And, they're located in the US or North America region. So what does that mean for a category manager? Well, the category manager has to go to their repository and they have to identify all of their IT software service contracts. Then what they have to do is they have to ensure that the contracts are still active as of last year. Then they have to determine what the annual spend was. Then they can go to the contracts and find all the payment term provisions and capture those, place them in a structured format, and then report back to the chief procurement officer. So that's just one really small scenario, but if you kind of multiply that against all of the commercial terms that may exist in your contracts and all of the great insights that you can garner from capturing that information, it's not really realistic when you have thousands of suppliers and tens of thousands of contracts to do that on a basis that's scalable. So our solution's really intended to reduce that effort while ensuring accuracy and quality in the results that we produce. So what I'm going to walk you through today is a demonstration of KPMG's AI solution called Cognitive Contract Management. And again, Cognitive Contract Management is intended to automate aspects or activities associated with your contract lifecycle management processes. So as I kind of mentioned, with that one scenario, when we speak with our clients, it's not synonymous to one industry or one line of business. There is a reoccurring theme of ineffective contract lifecycle management, whether that is, all of your contracts are stored on a SharePoint site, there's no level of organization, or that could be that, you have a really organized repository, but you are lacking in your ability to answer really, easy and useful questions, such as what are your payment terms for your IT service providers? And so technology is kind of catching up, and technology is now able to kind of help to get that level of organization in place, as well as automatically provide answers to certain questions that you may have. And why technology is becoming such an integral part of contract lifecycle management is that everything is moving to digital. We don't really rely on paper contracts that much. Things are becoming a bit more standardized. There's also ERP and CRM systems that are able to support and capture and allow for organizations to capture really useful information. But if you think about that as a go-forward process versus a historical process, the majority of our clients have a huge volume of historical contracts that did not follow the same processes as technology is allowing them to follow today. So that's where technology really does allow for and provide, very useful capabilities to help enhance and optimize your contract lifecycle management process. Okay, and I'll let the screen catch up really quickly. All right, so what does a CCM or AI contract lifecycle management process look like? Well, it's very similar to how a human would go about answering a question about their contract. So the payment terms for your IT service providers. We start with contract ingestion, and before maybe I get going, what each of these steps represent a different process or activity that takes place in an automated processing pipeline. So you start with the native contracts on the left, in their digital formats of PDFs, Words, TIFFs, JPEGs, And at the end, you get insights, whether these are just telling you what your payment terms are or identifying where there's potentially compliance or risk issues associated with your contractual provisions. So if we start with contract ingestion, what we're really aiming to do here is we're aiming to create that integration point between the solution itself, so the processing pipeline, and the location or the repository where your contracts are stored. That could, again, be a shared drive. It could be an SFTP. It could also be a production system, like SAP, like Coupa, like Salesforce, etc. So we want to do that integration, and we want to make sure that we can do a bulk pull of those contracts. So we don't want to upload things one by one. We want to download thousands of contracts at once. We want to ingest them into the pipeline. And once we do that ingestion, we're going to do some what we call pre-processing. And pre-processing is really intended to prepare the contracts for analysis. So this could be something like optical character recognition, converting a non-machine readable document into a machine readable format. And why this is really important is if you were to throw machine learning algorithms at a digital document, so a PDF file, and you ask those machine learning algorithms to provide answers to questions, the machine learning algorithms would fail because they don't really understand the context of what they're looking at. So that's why it's really important to also apply natural language processing. And natural language processing is intended to really teach these algorithms to read through and understand the content and context of the text just as a human would. So, when you teach a child to read, you teach them parts of speech, grammatical components, dependencies, and context. It's the same process for natural language processing. After we teach the algorithms to kind of understand what they're looking at in the context of how they're reading and interpreting and inferring information, we then can configure algorithms to look for very specific pieces of information in a document or in a contract, identify that information, and then return an answer. So this could be something like an effective date of a contract. It could be something determining if there's a late charge. It can also go beyond that, and it can also interpret very complex clauses like assignability, determining whether there is assignment rights, and if so, which party has that assignment right, and what type of criteria is associated with the assignment. After we get that structured data from the contracts, you can start to do more complex contract analysis, automated decision-making. We do this a lot for insurance companies where we assess their policies and utilize the information in the policies to determine whether deductible limits are compliant with their standards. We support legal a lot with the redlining and negotiation of contracts. Instead of having a lawyer have to read through, a 300-page document, we just point out where there's potentially a need for a trained legal eye to go back and review a red line or a materially modified contractual clause. And we can tell them specifically why we believe they need to go back and review that clause. So you can, reduce the review from, 55 provisions, maybe down to 2 or 3. So what I'm going to do is I'm going to walk you through each of these steps and try to make the components that I just described a bit more real. And so if we start with contract ingestion, in a perfect world, your organization has a very organized repository where contracts are sequenced appropriately and stored by a vendor or customer. The master agreement starts on top, and then all the child documents flow through in chronological order. That's very rarely the case. Many of our clients are still leveraging SharePoint systems, or maybe have more advanced, ERPs or CRMs, but still the effort required to create that level of organization is pretty significant. But for purposes of this, here's just a typical master service agreement. It's many pages long. And it also, contains exhibits as well as a pricing sheet. So this is a native format. We also have, a software license service agreement, very typical, where it has your fees, your standard terms and conditions, and then later on in the contract it has terms for maintenance services. So what we need to do is we want to analyze these contracts. And again, they're stored in a PDF format. And the first step of what we have to go through is we have to go through the process of ingesting those documents, downloading those documents, and then applying that pre-processing step I described, where we're converting those documents to a format that's suitable for analysis by a machine. And we understand that, not all contracts are in perfect quality. Some are rotated, some have scan marks on them, and technology allows us to clean a lot of those things up, because what we're trying to do here is we're trying to take that native document and create the best version of that is a machine readable, version and can be consumed and analyzed by these algorithms. So we remove those scan marks. We re-rotate and orient the document. We remove page breaks or any just noise in the document that may interfere with an algorithm's ability to make a very accurate decision. And so what you're seeing here is kind of that process. We're ingesting the documents, we're downloading them, and then we're doing that cleanup and conversion, ultimately arriving at a format of that document or a version of that document that has been cleaned up and is now suitable for analysis. After we get that document into a format that's suitable for analysis, what we then can do is we can go to that more advanced natural language processing phase, where we really begin to teach these algorithms to look for relevant information, to understand the content and context of that information that they're looking at. So what you see here is, I think it's popping up, so I'll hold off for a second. There we go. So what you're seeing here is you're seeing a free text version of the document we were just looking at. So this is a representative output of the outcome from OCR. So converting that PDF document into free text, machine readable, searchable language. And if, again, this is really good. It allows you to kind of do some Control X. You can find, relevant terms or keywords that you're looking for. But what we need to do is we need to teach the machine to understand this content in this context, just as a human would. So what I just toggled on or filtered on was a elementary representation of natural language processing. And each of the highlights that you're seeing on the screen represent a different part of speech. So the grammatical components of, 55 pages of contract text. And through this method, what we can do is we can truly help the machine learn to read, learn to understand how to interpret and identify dependencies within a master software license agreement, how to, catalog and capture different sections. And each of these, grammatical components aids the algorithm's ability to identify, interpret, and arrive at a correct answer based on the question that it's being asked. So now, after we've converted the documents to a format that's machine readable, the algorithms and the natural language processing components have been applied. The tool has a decent understanding of what it's looking at. Now we can get very specific. Now we can start to configure the algorithms to answer really specific questions about the contract that may be relevant. And the example that I'm going to show you here, when it comes up, is an example of the identification of language in the contract, and the answer isn't inherently present. And what I mean by that is it requires interpretation and derivation to arrive at that answer format that you're looking for. In some cases, like effective date, for example, effective date is inherently present. There's no interpretation that is required to arrive at the answer. It's more of finding the correct effective date of a contract. But in many cases, like, for example, the termination for convenience provision, it requires that the algorithm reads the entire termination section and then makes a decision to say, is termination for convenience actually present? And for those of you who may not be that familiar with contractual commercial terms of a contract, termination for convenience is a provision in the contract that determines whether either party can terminate or end the contract for any reason at any time without cause. So there's no constraints around why you can terminate this contract. So what we do is we show the algorithms a bunch of examples of true instances of termination for convenience and false instances of termination for convenience. And as we show the algorithms those examples, what they're able to do is they're able to learn the patterns and the keywords and just the nuances of that text. And so in the future, when a contract is processed and there's a termination for convenience provision present in that contract, it may not align exactly with what the algorithms have seen prior. But if we've done our due diligence and we've done enough work of training it on a lot of variations, the ability for that algorithm to adapt to a future variation that it hasn't seen is pretty remarkable. So what I'm going to do is I'm going to run through two models here. So what I just did was I kicked off the machine learning algorithm that's assessing this termination language to determine whether termination for convenience is present or not. And so as I kicked off that model, what you saw was in the middle here, you saw these decision trees and these different nodes light up. And I won't go into too much detail, but what this is really representing here is it's representing the algorithmic processing of this text. So the first step would be the identification of the text. Does termination language even exist? If it does, we're going to parse down this text and we're going to identify what we believe would be the most important language that would indicate a true instance of termination for convenience or a false instance of termination for convenience. The following nodes are just more post-processing, really decomposing that represented span of text, identifying if there's any dependencies in the document that would negate the decision that we're going to make, and then finally returning a true or a false answer. So the true or the false answer is what we consider the structured metadata that our algorithms produce. So instead of returning a paragraph of text for a human expert to review, we can go ahead and configure the algorithms to make a decision for them while providing the supporting information, as well as a confidence score associated with the decision that the tool made. So depending on the type of analysis that we're doing or the provision of the contract that we're assessing, there may be different appetites for levels of confidence. Maybe some provisions, 85% confidence is totally fine. It does not have a material impact on your financials. But maybe some of them are extremely important, impact your adherence to regulatory requirements, impact your bottom line, and there can be nothing less than 100% confidence. So any decision that the tool makes that's not 100% confident, a human will have to go back and double check. With this example really quickly, what I'm going to point out is I'm going to point out the first one and then the second one. So we're trying to determine, or the algorithm's trying to determine whether either party can terminate this contract for any reason at any time without cause. And after the machine learning algorithms have identified that termination language exists, what it then looks for is it looks for patterns of language that it's seen previously that indicates whether termination for convenience is allowed or not. And we returned a false answer here. And the reason we returned a false answer is because it says either party may at any time terminate a work order for material breach by the other party which is not cured within 30 days. So based on the guidance we've given the algorithms prior, we've told the algorithm that in this example, there's a criteria associated with why termination can be executed. And that criteria is material breach. So there's really no indication that you're not confined or not constrained with your reasons for terminating. But if we go and run the model here at the bottom for this example of termination for convenience language, you notice that the language is very similar. Dylan may terminate this agreement upon licensee's material breach of this agreement if licensee has not cured such breach after 30 days. So the reason why machine learning is very important here is because if we were to rely on very specific rules or templated text, likely the algorithm would have said that this was a false example. Termination for convenience was not present. However, by applying machine learning and kind of letting it read through the entire document and not stopping when it sees language that it's seen prior, we're actually able to capture the sentence at the bottom here. And the sentence at the bottom says, licensee may terminate this agreement for any reason upon 60 days written notice to Dylan. So we know that this last sentence is truly indicative of termination for convenience, and it supersedes what it's seen prior. So thus we return a true for this, this example or this contract with a 97% confidence level. And so what you're seeing here is a representation of creating structured data from your unstructured contracts. And once you have this structured data, you can then go to the more advanced phases of our processing pipeline, and that would be the contract analysis. So that structured data really does allow for automated decision making. And as I mentioned in kind of my description of the overall pipeline, we've done a lot of work in the insurance space, and we help our insurance clients with automating or reviewing their insurance policies to make sure that everything aligns to their standards. There's nothing inherently wrong or erroneous or will expose them to risk or loss as they execute these policies with their policyholders. So imagine that we are interested in automatically assessing whether the wind deductible limits in this policy comply with the standards of the insurance group. And what we'll do is there's specific decision points or a decision tree that can be defined. And each node of the decision tree represents different data that is extracted and returned from the insurance policy. And based on what information is actually present in this policy, we can automatically derive a output such as your wind deductible policy limit in this policy is totally fine. No compliance issues whatsoever. And so what you kind of saw highlighted there, and I hope it came up clearly on your screen, the first question we ask ourselves is, what is the geographic or the country where this insurance policy provides coverage? We're specifically interested in understanding where in the United States does this insurance policy provide coverage? Is it considered a tier 1 or tier 2 county? And what type of account is this policy covering? And so in this case, it's in the USA. It's a state south of Virginia all the way to Mexico. It's considered a tier 1 county. It's a manufacturing account. And thus, the wind deductible limit must be greater than or equal to 10% of your total policy value. So when we assess all the data elements that we captured against this decision tree, we can automatically determine and provide a compliant result. So this wind deductible for this policy, based on the data that was present, has no compliance issues. And so if you think about doing this at scale for a large insurer that has maybe tens and tens of thousands of policies, it does provide significant value, efficiency gains, and also reduces your exposure to any risk or overpayments or erroneous coverage that you may not be intending to provide. And so I would categorize this as, pretty specific business rules and intelligent assessment. But now, if we're really interested in getting to the more advanced components of machine learning and artificial intelligence, this is one of my favorite examples. We were helping a large oil and gas company in Texas, and their procurement practice ran into the perfect storm of all of their major software license agreements were expiring at the same time. So what they were doing is they were preparing a war room of lawyers to help with the renegotiation process. And anyone who has experience working with the large technology companies knows that's not a very easy process. And so they had hundreds of agreements that they had to go through. And what they were looking for is they were looking for KPMG's help to employ this tool to reduce the amount of reviews that their lawyers actually had to do. So what you're seeing here is you're seeing a heat map, and the different gradients of colors here represent the priority of reviews that need to be conducted. So on the left side, we have all the different documents. Represents the type of contract they are, so software license, cloud applications, IT professional services pertaining to software license. And at the top, what we have here is the key contractual provisions that they were in. What we were able to do is we were able to actually work with the attorneys and define a set of logic that would indicate whether a lawyer actually needs to go back and review this provision or not. So throughout the entire negotiation process, we would just continually run this. So every time a red line came through or a new version of the contract came through, we would be able to apply our machine learning algorithms and then determine if there was any discrepancies with what they deemed standard or what they deemed acceptable. And so if we open one of these up, and maybe this one's a good one, where we assessed one document, and in the contractual provision or the section of the document we were interested in was the information technology and compliance reports. And the red fill here indicates that there's a major discrepancy, meaning that the current version and the current language of that contract does not align with what this oil and gas company's legal team deemed compliant or would be acceptable. And so instead of just saying that this provision has something wrong with it, we're actually able to teach the algorithms to tell us why something is wrong with it. So it's not only just flagging it as this provision has a major discrepancy, it's actually giving you an error. And the error is that this is missing key elements of the information technology compliance report. And probably to us, that doesn't make any sense, but to a a trained lawyer who works with these contracts a lot, that's probably a immediate light bulb that says, I know what's wrong with this. And we can also include, in some cases, let me see if I can find a good example, which is not showing up here. In some cases, what we would do is we would actually return what the standard language was, or the more acceptable language, in comparison to what is actually in the contract. And the lawyers could actually go back and do the redlining directly in the user interface, push that to the current version of the contract, and really accelerate their review in its entirety. I would, just to kind of close out with this, what we look to achieve here is we aim to accelerate the process of all the contract lifecycle management activities. So whether that's the speed at which a contract is executed, the speed at which a contract is reviewed, the speed at which issues in the contract are addressed, there's efficiency gains here, and those are obvious. Obviously, there's a cost reduction. The cost reduction can be an FTE cost reduction, but it can also be related to compliance. It can be related to risk. It can be related to identifying non-favorable commercial terms, or identifying preferred rates or preferred suppliers across your entire population of suppliers. It can also be used for mergers and acquisitions to identify synergy savings opportunities. If you're acquiring a new, a new organization, or you're divesting, what contracts can be terminated because your acquiring company has more favorable terms, or there's better rates. And then obviously risk. I will say one thing that maybe is a bit off topic. One of the benefits of leveraging machine learning is that machine learning algorithms don't get tired. They don't make objective decisions, they don't make subjective decisions, and they're trained based on human expertise. So none of these algorithms are configured in a black box. How it should work is that we work with the experts, and the experts' logic is used as a kind of input and our configuration parameters when we're teaching these algorithms how to look for information, how to interpret that information, and ultimately how to provide a result. So, it's all based on translating human expertise into the mechanisms and the logic that the machine learning algorithms use when assessing these contracts. And that is actually it from me.
All right, thank you very much, everyone. I will, Simon, we will turn it over to you to talk about, our next example here.
Sounds good, Pete. Good morning, everyone. This is Simon Besrikov, and I'm one of the data science leads in our unstructured data practice. And Dylan, it's funny. Every time we talk, I feel like I learn a little bit more. So in your segment, I think in teaching a machine to understand documents, that's pretty amazing. What we wanted to cover with the group this morning is the different kinds of mechanisms and different kind of thinking that we use and that your organizations might benefit from when it comes to actually taking documents and then converting them into machine-readable text. And so I think for the purposes of a little bit of engagement, there's going to be a survey that's coming your way. If it hasn't been sent out yet, it should be headed there momentarily. We have a question to the group around the specific kinds of technologies that your teams use to extract data from these unstructured documents. And don't worry, there's no wrong answer. Because honestly, there isn't a huge difference between the specific OCR engines. The OCR is optical character recognition, right? Those are the components of any kind of a machine learning pipeline that take the documents and then make it machine readable. And so even in our business, we recognize this problem that we oftentimes face when it comes to actually taking documents which are not parsable by machines, right? So predominantly I'm talking about PDFs. And how do we pull this data out of them? And so what we wanted to show you some of the advances in thinking that we're doing in creating some of these techniques. But to start, what I'd like to do is share with you first the sort of the 3 E's, right? So we're framing this as different challenges of trapped data. And so we like to think of them as expense, exposure, and efficiency. So when we talk about expense, we feel that in our experience, there are a ton of expenses that are incurred by any organization that extracts data from documents, especially if any part of your extraction relies on manual processing. So in terms of some of those benchmarks, there's some reports. So Forrester, this one in particular was very interesting and actually very consistent in terms of what we've seen with our clients, where a single page of a complicated invoice costs about $30. Right, that's both paying for the time of the person to take that document and effectively type it in if you're running a swivel chair operation, and then also do additional QC on top of it, et cetera. And of course, the prospect here is cost savings, right? So if I take this data and I come up with some magic way to digitize it, how much can I save? Well, at least 44%. Exposure also is very interesting, right? That's the other element of cost, because we've seen clients that incur significant liability, either for fines, right? So if you're subject to a regulator, but even commercial clients, right, where you might be losing your customers, right? So there's lots and lots of information that might be present in these documents that if you had access to, you might be able to make better decisions. And once again, Forrester says that there's lots of this information out there, right? So majority of enterprises have 100 terabytes and a few are in the petabyte range. And then kind of like the statistic that Pete shared with you at the beginning of our talk is we do feel that, around 80% or more of this data is unstructured, right? So we need to basically put it through some sort of machinery to get the text out. And then we can do, the kind of analysis that Dylan was talking about when it comes to teaching the machine to actually understand the contents of the documents. And then, of course, last not least is this efficiency, right? Because if I'm processing these documents and I'm trying to extract the information, there's going to be a great deal of difference in the quality of these documents. Some are going to have handwriting. And I hate to be the bearer of bad news, but if somebody tells you that they can pull out handwriting from your documents, I would be very critical at that. There is really no technology on the planet that can reliably do it these days, right? Which intuitively means that some older documents will always be a candidate for some kind of a manual data entry. This last tidbit is actually very interesting. So there was a recent CIO survey that said that data, right, the unstructured data, has become the number one concern of all CIOs, beating cyber, right? I've been in this business for a very long time, and this factoid has really amazed me personally, just because cyber has been so much at the forefront of what CIOs care about on a day-by-day basis. And then last but not least, right, some of these scanned documents are going to be very poor. So the question at hand is, right, are we missing an opportunity, right? Could there be some kind of a solution, right, that would allow us to look through all of our documents, identify which ones are important, and then pull out information from them in a very accurate fashion? And so one of the things that we're going to do during the talk today is take a look at different schools of thought behind how you could attempt that in your enterprise. We're going to look at a couple of examples and case studies where accuracy is paramount, right? And of course, some of that's going to come down to, basically anytime human lives are on the line. But sometimes in the regulatory domain, right, accuracy is going to be paramount for an entirely different use case. And so once again, here we're looking at our documents, unstructured, right, predominantly PDFs, Excel, right, even though sometimes we think that Excel spreadsheets are structured, they're not tagged, right? So if you wanted to go through and pull out the data that matters from an Excel or a Word document, for the purposes of this discussion, we'd like to lump them in with unstructured documents, but even sometimes pictures, right? You might have TIFFs or JPEGs, which are photos of important documents that you need to figure out a way to digitize. So how do you do it? In the industry, there's effectively 2 or 3 ways, right? And so when I like to think about it, I like to think about sort of the 3 KPIs, right? So what are my most important parameters when I'm going to evaluate building some sort of a mechanism to get the data out? So here on the left, I have the 3, right? Human, machine, and then some sort of a hybrid solution which incorporates sort of best of breed. So if I am using a purely human operation to pull my data out, what does that do to speed, accuracy, and cost per page? And we've selected these because they're pretty easy benchmarks, but also they give us an objective view and a criteria to compare between these 3 approaches. So speed means literally speed to value. So I give you a set of documents. How quickly is it going to take for us to take them and transcode them into machine readable text, right? Or something that I can Control F and find data in. Accuracy is actually not that bad, right? Because you're using humans. Humans are great at making tough decisions. So, if you're trying to interpret handwriting or look at a document that is really old, right, and is pixelated, humans are actually pretty good at this. The problem is human bias, right? And if you are outsourcing operation, then there's going to be some sort of difference, right? If I'm asked to make a tough decision versus yourself, we might interpret the contents of the document differently. So your accuracy is going to be high, but because humans are involved, right, the counterpoint is that it's not going to be perfect. And then cost per page is going to be high, right? So using this approach doesn't scale particularly well because it scales linearly, right? The more pages you have, given the same amount of document content, the more human data entry folks you're going to need. So let's take a look at what that looks like for a machine. So let's say we have some sort of a magic technology out of the box, and we use it exclusively to be able to pull the data out. As you might imagine, right, the speeds are really high. The only thing you're paying for is, your AWS instance. You spin up a few more VMs, right? You allocate a few more machines to do it. Similar to cost per page, right? Because it scales very, very well. Once you spend the initial money and effort to develop a mechanism for automation, it's going to continue working, going forward. But what is going to be highly variable is this middle bar, which is accuracy, because machines can't really infer context. And even if my documents are fairly straightforward, it's difficult for us to control the quality of the documents. And especially when we're looking at older, PDF docs, which still comprise, in many cases, majority of your volume, a machine is going to struggle, right? And that's going to give you results which are fairly unpredictable. And so this is where hybrid comes in. So in our experience, a lot of our clients which are dealing with business problems that require perfect or next to perfect precision rely on this model. So what we're going to show you is how we think about picking, what humans do best versus what machines do best, and putting this together in some sort of a solution that really emphasizes accuracy. It's still going to be pretty good in terms of speed, right? Cost per page is also going to scale. So obviously we have to give up something, right? This is sort of the fast food triangle of, good, cheap, and fast. You can't really have all 3. But by very smartly picking the best attributes of each, I think we can go and get a lot of this, actually quite a bit. So what we wanted to show you today is something that we call CLEAR, which is our methodology for solving this problem. CLEAR conceptually stands for classify, because that's one of the things that machines are pretty good at, right? So assuming that we encounter documents of different types, we need to separate them by document type. E stands for extract, right? So it's a set of different computer-driven techniques to be able to take certain features of the document, right? Certain fields, and be able to pull them out. Then there's analyze. Analyze is important because that's how we look for inconsistencies. And it's all underscored by this R, which is review. And the point of this methodology is that we want to be able to smartly escalate certain components of data entry to the human operators in order to minimize this burden. But in order to have hyper-precise, hyper-accurate extraction, you're still going to need to involve humans in some fashion. So in order to make this real, what we wanted to do is share with you a quick case study of some of the work that KPMG is helping to support for our state and local clients. And this, as I mentioned, is one of the kind of rare and privileged instances where human lives are sort of on the line. So the focus of this work is around looking at allocation of EGT, so educational good time credit, to inmates of various jails and prisons around the country. So if you are unfortunate enough to be incarcerated, there are multiple programs that are offered by the state that might help you reduce your sentence. So what that means is if you take those courses, a lot of them focus on moral recognition, right? So recognizing that you've done wrong, rehabilitation, and then also development of skills that would allow you to be successful after you exit prison. So they adjust your parole eligibility. And the way that it works is if you can demonstrate that you have successfully completed this program, right, typically by presenting a certificate or a diploma to an appropriate approving agency within the state and local government, they are mandated to acknowledge this and then reduce your sentence. And then the actual reduction varies from program to program, but for vast majority, we're talking about 60 or 90 days. And as you might imagine, if you're incarcerated, you don't really have a ton to do, so you might be taking a healthy advantage of this program. So what we wanted to show is how CLEAR was built, because it was purposefully built for this use case. And we added a couple of more elements here to the framework, right? So we're going to once again talk about this whole classify, extract, analyze, all underscored by review. But we added this ingest box. And of course, insights, right? Because we wanted to demonstrate, tractable benefits that this offered the client. Of course, all the data you're about to see is completely de-identified for the purposes of this demonstration. But the interesting part, and I'm going to take this ribbon and put it on the left, is that each of these boxes can have a hybrid component. So it doesn't have to, but most often the best practice is to build some sort of a smart escalation in every single one of them. And here are the reasons why. So for the purposes of ingesting, right? So you might have information in lots of different data sources. So in this instance, we got a ton of email accounts, right? So literally Outlook, PST files. We got a ton of file systems and even some hard copy packages, right? So there was a little bit of everything. The challenge was, how do we take all of these documents and then aggregate them? Because when you're talking about email accounts, you might imagine that there are email threads, right, which might refer to the same document multiple times. So the ability to extract these, de-identify them, and then put them together so that we have access to the metadata is really valuable, because you can start with a huge volume of incoming data. But then by smartly sort of filtering it and aggregating it, you end up with a smaller volume that you actually run through your, your OCR solution, right? So in this case, we started with many millions of documents, and we ended up with a few million pages and these references, right? Because sometimes these documents are hierarchically linked. Classification, once again, I think Dylan talked about this for a bit in his part of the presentation, but it's intuitively very simple, right? You want to take some of these, and for this particular client, it amounted to being able to take all of these and split them into 3 categories, right? Certificates, transcripts, and diplomas. The way that happens sort of behind the scenes is that you have a machine that goes through, and there's a variety of different techniques. We just happen to use a neural network. But you teach the machine by showing it examples, right? You say, I'm going to go through, 100, 200 of these documents by myself. I'm going to label each one what it is. and then the machine learns to be able to tell them apart, right, based on the features of the documents. But it's very important to realize that that's not always going to be the case. And so in this instance, we came up with a way for a machine to be able to identify particular documents where it wasn't 100% certain. And those were escalated to a human operator for review, right? So here you can click on each one of these documents in the system, but for these ones in orange, the confidence rating was fairly low, right? So what we did is then the green ones just kind of went all through to the next step. But for the orange ones, we brought them up to an operator, showed them this document, and then said, hey, the machine thinks that based on the text that's contained in this document, it is a certificate. But it's not 100% sure, right? Because it could be a poor quality of the document, or maybe the wording is slightly different because, the document was issued by a different agency. And so this allowed them to manually apply this classification. So they would look at this and they say, oh, hey, this is actually a cert. We're going to apply it and then move on to the next one, right? And so it'll be colored green here in just a second. And so using this kind of an approach, a very low volume was actually escalated to human beings for review. And then also, as you get better at this, right, as you crunching through these exceptions, you're also retroactively adding them back to the machine learning step here so that over time the machine gets smarter, right? Because once you have humans who've confirmed that, this document, hey, this is in fact a certificate, then you go back and you show these as examples to the machine again, and it gets better over time at identifying these, right? So there's definitely a feedback loop going on here because the premise of the AI is that, over time it gets smarter. And for this particular instance, this was exactly the case. When you extract data from the documents, right? So let's say you have a whole bunch of, graduate, like GED, so high school diplomas. So you're going through them. You can use different kinds of standard template matching techniques to pull the data out, right? For instance, you know that the name of the person is going to be in the center of this certificate or diploma. You know that the name of the school is probably going to be towards the bottom. But in some instances, there are going to be gaps here. So what we try to build, or we urge our clients to develop, is this sequence of extract the data out, come up with an automated sequence to validate some of these rules. So when the algorithms got to this page, right, automatic validation, there are very simple rules that you can code into your system that basically look for anomalies. And some of them can be completed automatically, right? So in this instance, I'm showing you on my screen that this person's name, Will R. This one wasn't capitalized. Well, guess what? That's not a huge deal, right? And in some instances, they can be fixed automatically by the automation, right? So it can go back in there and it can correct them. Sometimes the algorithms can be smart enough to actually fill in some gaps. So for Will R, once again, totally notional data, but we try to pick a unique name, right? So this combination of a last name with this combination of a first name, if we didn't have a unique ID for this person, and DOC number is kind of like your social security number in prison, right? It's unique. It uniquely identifies a person. And so, for somebody like this, right, who is a fairly unique individual, a machine can actually go and fill this in. But there will certainly be instances where some fields a machine can't figure out, right, because the quality of the document is poor. And so, so in this instance, we created a system which basically flagged anytime a gap was encountered, and then allowed a reviewer to simply go to one of these documents. The system pops up a doc, and then a human reviewer just types in the particular program name, right? So it looks like same person here took a program called substance abuse, so on and so forth. Now, once you have this information, right, the real value is in being able to make the match. And as I already alluded to, the issue at hand was in assessing whether the prison and jail system was accurately allocating credit to these offenders. And as you might imagine, in the majority of the cases, that was that was the case. But the goal of the program was to find instances where credit was given inappropriately, right? So this might be double counting, right? So a person who actually only earned 60 days of a reduction, but was given 180, right? So probably a double counting mistake. Now, in these red instances, that's a much more egregious error, right? Because this person was due some time, they weren't. And the reason why that happens is because frequently the processes that are used to record this credit are, they don't work particularly well, right? Because they're fragmented, right? So there might be one process that exists for acknowledging GEDs, and then there might be an entirely separate process that is currently in place for acknowledging, a completion of a different program. But once you have all this data together, the beauty was that it lets you do course of action analysis, right? You can figure out exactly why things are broken in your current system, right? So in this instance, you can say, okay, what are the number of errors by program, right? So maybe in the instance of GED, relatively speaking, there are few errors, fewer still for the substance abuse program, because maybe it's administered by an external party that does its own collection of these certificates and diplomas, and then reports back up to the jail and prison system in some sort of on an automated fashion, right? Versus this program, electrician level 2 or relapse prevention. Maybe whoever is administering that program doesn't report automatically, and it's incumbent on the offenders themselves to self-report. And for one reason or another, our process doesn't work particularly well. Maybe the error instead is linked to a geography, right? So maybe in a certain county, there's a better system for acknowledging these credits than in others, so on and so forth. And so what I wanted to show last is sort of how this helps our clients redesign their processes, because they are very complicated. Sometimes they require, actually shipping physical documents, right, instead of electronic completions. And as you might imagine, there are multiple pain points or issues that happen in this process. And the goal is to take something that's as complicated as this and then transform it into a streamlined process, right, that looks something like this, right? So a common integrated process, not program dependent. And, doing this process redesign is something that clients are really looking forward to, because in the end, that saves them money. Right. So one of the, very positive outcomes of this program was that, of course, we looked through, a ton of documents, we processed them, we found the errors, but most importantly is the impact that we're having on human lives, right? By helping our clients identify these errors, right? Identify issues where they would have made errors both made errors in the past and would have made errors in the future, and it translates to tremendous cost savings, right? Because if you continue making errors and you keep people in jail for longer than they're due, aside from breaking the law, because everyone's entitled to due process of law, you are incurring costs which can otherwise be deferred through early release. So I'll leave you with a thought on these last 4 tiles here, but when you think that you need full confidence in your extracted data, you need to make sure that you have available to enable sort of this kind of transformative analytics when you're thinking about creating a streamlined process that scales significant. And then, of course, if you do that, you can achieve very significant long-term cost savings. We encourage everybody to think about hybrid solutions, right? So how do we pick the best from, pure automation and AI, machine learning, all that fancy stuff? But ultimately, how do you couple it with, traditional data entry? Because there's definitely a sweet spot, and the weights can be biased towards automatic techniques, but in total, that can allow you to create solutions that are hyper accurate at extracting data from your documents.
Right. Well, thank you, Simon. That was really great, and I think complemented what we saw with the contract analysis in the beginning very nicely to kind of pair them together. I think that's all the time we have for today. So hopefully everyone found this valuable. Feel free to send any questions our way, and we'll get back to you with them after the fact. And Mary, I'll pass it back over to you for the final instructions.
Great. Thanks, Pete. Just want to thank everyone again for joining us today. Before we close, I have a few housekeeping items to cover. When the webcast is over, please do not close out of your web browser completely. The player will automatically refresh to display an exit survey. Please complete the survey and then click the submit button. If you met both the duration and polling requirements for CPE credit, you will receive your certificate via email at the email address you entered when you logged in approximately 2 weeks. On behalf of KPMG, I would like to thank our speakers as well as everyone who joined the webcast today. Up next, we have session 2 starting at 10:30. That session is titled Low Code, No Code, and the Low Barrier to Entry for Automation Today. To access that session, you can go back to the portal page you used to log into this webcast or your confirmation email. So hope to see everyone there and enjoy the rest of your day.